our electronic balances to check our measurements. We're going to turn it on by pressing this on button right here. And make sure that I have it in grams. That's the grams right there. I'm going to hit the mode button until it's in grams. This one's already in grams. Now the reason why I have two different balances is because this one only goes up to 500 grams and this one goes up higher. So I'm going to measure the smaller things with this one. I'm going to measure the larger things with this one. So the first thing I'm going to measure is my pencil. I'm going to use this one. Now I want to make sure that it's set at 0. If it had a different measurement on it, like that, then I will hit this little tare button, this little T button, to re-zero it. So I'm going to go ahead and put my pencil in there. And my electronic balance says that it's exactly 10.00 grams. We'll write that in our data table and compare that to our triple beam balance measurement. The next thing that I'm going to measure is the large eraser, actually the 10 milliliter graduated cylinder. And I'm going to put that on there because that had a little bit smaller mass. So that says that the mass of the graduated cylinder is 25.77 grams. We're going to compare that, write that in our data table, and compare it to our triple beam balance measurement. Our large eraser has a mass of 14.50 grams. Now, and I'm going to go ahead and do the shell on this one too. That has a mass of 9.11 grams. All right. I'm going to do the larger objects on the other balance. Now, say if I had a container, like say this graduated cylinder here, and I wanted to find the mass of water that I might put in that container, on the digital balance, I would just have to hit this little T button. So once I have my mass for my container, I can hit this little T button and it re-zeros it. I can add water and it'll give me just the measurement of my water. On a triple beam balance, I just have to subtract the value of the graduated cylinder from the value of the water plus the graduated cylinder. Now let's check the larger ones here. You see how that went down because I took that off? I just have to hit that T button again and I'll give it to 0. So let's check our larger objects. Let's start with the big rock, the large rock. Now this one doesn't get as accurate as the littler one, but it does measure bigger things. So let's say that our large rock has a mass of 210.3 grams. We're going to write that in our data table and compare it with the mass that we found on our triple beam balance. For our test tube rack, try to get that all on there, it's saying it has a mass of 172.1 grams. We're going to compare that with our triple beam balance measurement. For Bleck, he has a mass of 47.5 grams. And for our paperweight, it has a mass of 442.2 grams. So record your masses in the electronic balance or digital balance column of your data table, and then find the difference between your triple beam balance value and your electronic balance value. Hopefully they're pretty close. If not, we may need to remeasure. One of our instruments may be calibrated wrong, either triple beam balance or the digital balance, or maybe there was just, human error. Maybe I didn't measure on the triple beam balance quite right. It's always a good idea to check your measurements, especially if there's a discrepancy. Thank you for listening. Please email me if you have questions, or you can join me for a Google Meet.